more more header overhead than device data again. Consequently, what happens? You need to decide whether the IP adoption model is necessary, and if it is, how it can be optimized. First point. Second point is the same consideration applies to control plain traffic, that is run over IP for low bandwidth last mile links. Third one, routing protocols and other verbose networks services may either not be required or call for the optimization. Without the optimization, the communication is difficult. Okay. Next, data flow model. How the data is going to get communicated, basically. So the one benefit of an IP adoption model is that the end-to-end nature of communication. Any node can easily exchange the data with any other node in the network. It's a common. Although security, privacy and other factors may put controls and limits on the end-to-end concept. Very important thing. As the node is going to exchange the data, so we should be careful about security, its privacy and other factors for the communication. However, in many IoT solutions, a device data flow is limited to one or two applications. Not much applications. In this case, the adaptation model can work because translation of traffic needs should occur only between the end devices and one or two application servers. So, IoT solutions are going to be adapted for only one or two applications, not like an IP. Depending on the network topology and other data flow needed, both IP adoption and adaptation models are going to be used to play in last mile connectivity. Then finally we'll come to the network diversity, where a lot of changes are going to be there. As you'll be knowing that different types of networks are going to exist and protocols are also going to exist. So based on those things, that diversity is going to be plays a major role. Here, one of the drawbacks of the adaptation model is that it depends upon the single physical and MAC layers. MAC is media access control, PHY is physical layer. For example, ZigBee devices must only be deployed in ZigBee networks. We cannot adopt these things in other networks. Okay. Therefore, a deployment must consider with applications how to run on the gateway connecting these islands and the rest of the world. So here integration is must. So the integration and coexisting of new physical and MAC layer or new applications impact how deployment and operations have to be planned. So this is not a relevant consideration for the adaptation model. So we are not able to make it as an adaptation model. What is the need for an optimization basically? Why we go for optimization? So here we are having the Internet of Things will largely be built on the Internet protocol suite. In coping with the integration of non-IP devices, we need to deal with the limits at the device network levels that IoT often imposes. Without optimizing the data, we cannot able to send more data to the required locations. So we need to have the optimization. There are so many layers are there. Each and every layer, the data has to get optimized, shrinked. Then at the end, it should be unpacked and it's going to get releases. So there are so many restrictions are also going to be there. The concepts take a detailed look at why optimization is necessary. So let us see one by one. Here the first point is constrained nodes, constrained networks and IP versions. What do you mean by this constrained nodes? So IP is having different classes of devices coexist. Depending on its functions in network, a thing that is in the architecture may or may not offer similar characteristics compared to a generic PC server in an IT applications, IT environment. Another limit is that this network protocol stack and IoT network may be required to communicate through an unreliable path. Data is going to get connected, but whether it is reliable, not reliable, so we should check it. Whenever that we are going to connect the devices for the banking sector, where the finance is involved, if communication happens in the non-secure mode, there is a threat of leakage of passwords and the hackers can hack it. So we must aware of where we are implementing this particular things, where we are communicating, that we must monitor. And here what happens basically, even if a full stack is available on the nodes, this causes problems such as limited or unpredictable thoughts of low convergence when topology change occurs. So topology is going to change. So unpredictable things are going to happen. So to avoid that, we will go for constrained networks. What happens in case of constrained nodes? How that power consumption is a key characteristics of constrained nodes. What is that? It is basically it's a battery enabled with the lifespan of months to 10 years. It's a long time. It's good. Cost is going to be more. Battery powered nodes impact communication tools. The node one that is always on, instead another option is that always off, which means communications are enabled only when needed to send the data. Very important thing. So if you want